Refraction also involves a light beam changing direction, but refraction is the changing of a light beam's direction when it travels from one transparent substance to another. For example, air, water, glass, and many types of plastics are said to be transparent because light can pass through these materials and we can see what's on the other side. But whenever a light beam does pass from one transparent material to another at an angle, the light beam changes direction. That is, it refracts. Here, for example, the light beam travelling in the air hits a glass block at an angle and then changes direction, or bends when it enters the glass block. The light beam has refracted. When the light beam then hits the other side of the glass block, it passes from the glass block to the air, and so it changes direction again. The light beam has refracted again. In fact, in this case, the light coming out of the glass bends back the same amount as it had bent when it entered the glass. So the beam ends up travelling parallel to its original direction, but slightly displaced. So why does refraction occur? Why does a light beam change direction when it goes from, say, water to air? Refraction occurs because light travels at different speeds in different substances. In a vacuum, for example, no, not a vacuum cleaner, a vacuum, which is a space which has no air or anything else in it, like what you'd find up in space, light travels at a speed of 300,000 kilometers per second. Although, if you want to be really accurate, it's actually closer to 299,792 kilometers per second. In air, light also travels at close enough to 300,000 kilometers per second, but slightly slower than what it does in a vacuum. Through water, light travels relatively slowly at about 225,000 kilometers per second, while through glass, in for example windows or optical fiber cables, which we'll be talking about later, it travels at only about 200,000 kilometers per second. By placing two identical rulers next to each other in two identical containers, we can see that from this viewing angle, the part of the ruler underwater appears to be about 30% shorter than it really is. The exact appearance changes depending on your viewing angle. From this viewing angle, it's more than 50% shorter. From above, there's not much difference because the light coming from the bottom of the ruler travels almost straight up and doesn't refract much. As your angle gets lower, the distortion increases because the light refracts more.